Hi, in this small video, I want to show you a general technique of how to solve certain class of problems. We have a summation here. Basically, we have to sum up k from 1 to n, k square by 2 power k, right? So how do we go about solving it? So what I want to show you is a technique called generalization. So it sounds very obvious, but it's an interesting idea here. So what am I saying here is right now this summation might involve some tricky calculations. You have to do 1 square by 2 power 1, 2 square by 2 power 2, and then 3 square by 2 power 3. It is not clear what strategy you would take if you just try to directly find it out, right? It may be possible to do it by some method, but it's not very clear immediately what to do, right? So what I would do here is take advantage of the fact that we know so many things in calculus, and we are going to convert the problem from an algebra problem into a calculus problem. How do I do that? I generalize. So instead of trying to find k square by 2 power k, I'm going to find the sum of k is equal to 1 to n k square into x power k, where x is a variable, and I will call this as a function of x, so s of x, and later my job is to find s of half, right? So if I put x is equal to half, I get the series that I need, right? And I'm going to try to evaluate s of x. Why is this better? Think about it. Why is this better than before? This is better because we know things like how to do sum of a GP, right? We know a GP sum formula, right? And we also know if you have a function, you can differentiate and integrate it, right? We can do all the techniques that we know in calculus, we can apply. If it was just k, then this variable k is a discrete variable. Discrete variable k goes from basically k is 1, 2, 3, and so on. So we cannot differentiate when k is a number or an integer. We can differentiate here because x is a continuous variable, right? So you will see why differentiation becomes important here. But for now, you realize that there is far more tools available to you if you have a continuous variable, because you can do calculus with continuous variables. You cannot do calculus when the number is an integer and its value changes from 1 to 2 and all, right? So let's see how to approach this problem. I want to find out s of x, right? Now I already know that sum of x power k, where k goes from 0 to n, is equal to 1 minus x power n plus 1 by 1 minus x, if x is not equal to 1, right? Now I'll use the commonly known techniques which you have probably learnt in binomial theorems and while summing up binomial series, how to change a particular summation and differentiate and integrate to get a particular form, right? So what I will do, I'll use this formula and do some manipulations on it so that we convert it to this, right? So I'll do it on the next screen. So let's see, we have summation k goes from 0 to n, x power k is equal to 1 minus x power n plus 1 by 1 minus x, and I want to finally find out summation of k square x per k, where k goes from 0 to n, right? This is what I want to find out. I have this right now. So what I do is first I will differentiate with respect to x, both sides. So this will become summation of k is equal to 0, n k x power k minus 1 is equal to, now we get 1 minus x. I'm going to differentiate this by quotient rule. So be careful while applying it because it's a complicated looking fraction. 1 minus x into minus n plus 1 x power n minus 1 minus x power n plus 1 into minus 1 divided by 1 minus x square. This is what we are getting. So we have gotten 1k here, right? Great. If you simplify this a little bit, you will get 1 minus n plus 1 x power n plus n times x power n plus 1 divided by 1 minus x whole square. This is coming as summation of k goes from 0 to n, k x power k minus 1. right? Now, if I want to get to this point, I need k square. I don't just need a k. And I need x power k. So I'll multiply by x, both sides. So here I will get summation k goes from 0 to n, k x power k, and that becomes basically x minus n plus 1, x power n plus 1, plus n x power n plus 2 divided by 1 minus x whole square. Now you sort of get the pattern, right? You get what I am going to do now. I'm going to again differentiate with respect to x. Then I will get k square x power k minus 1, and then again I will going to multiply by x. So there are two more steps involved. I will leave the calculations to you. I will show you what comes. So once I differentiate, I will get basically k square x power k minus 1 is equal to something complicated. Then I'll multiply by x again. So I'll get k square x power k, and k goes from 0 to n. And finally, after multiplying by x, you should get finally this x into 1 minus x into 1 plus x minus x power n plus 1 into nx minus n minus 1 whole square minus x power n plus 2 whole thing divided by 1 minus x whole cube, right? This is what I am getting finally. Obviously, it involves a lot of steps and one differentiation which is super annoying. The last differentiation which I have not showed you. But ultimately, the problem is difficult. So you can't avoid doing some work, right? So here at this stage, we'll put x is equal to half, and that will give us s of half. And that is basically summation of k goes from 0 to n, k square by 2 power k. And that answer should come out for you as 6 minus n square plus 4n plus 6 by 2 power n. So when you put x is equal to half in this expression, this is what should finally simplify and come for you, right? So just check this expression for small values of k or small values of n. You can do this summation for k is equal to 0 to 3, 0 to 4, and check whether this formula is correct or not, right? Hopefully you will realize that it is correct. But the main idea in the problem is to understand the value of converting a general series question into a function question, into a calculus question. And we did that by going from the discrete to the continuous variable, right? We had k and n earlier, and we got it into the form of x. And when you go to continuous variables, you can use methods of calculus. You can use differentiation integration. So that is a very important idea. You have seen such ideas being employed in binomial theorem problems before. Binomial series summations, you have probably seen this happening before. But keep in mind that you can do it in other situations as well, right? Hopefully you learned something from this video. Uh, we'll have more videos coming for you soon. See you in the next one. And please like the channel, subscribe to the channel, share it with your friends, and help me continue doing what I'm doing. See you next time.